Okay, 15.2, homogeneous aqueous solutions. So this is a good review of some vocab that you might have gone over way back at the beginning of sophomore chemistry, the difference between a heterogeneous mixture and a homogeneous or homogeneous mixture. And the big difference there is that in a homogeneous mixture, a mixture that is uniform in composition and the components are evenly distributed and not easily distinguished. So we're going to take a moment and write that down. Mixture that is uniform in composition. And what does that mean? That means that, if you take one sample of the mixture and then another sample of the mixture, those two samples will be exactly the same. Think about salt water. If I have a glass of water and I take a scoop of salt in and I stir it all around so that it dissolves, and then I take one scoop of water and another scoop of water, they'll have the same concentration of salt in. We would say that it has a uniform composition. Another way to say this is that the components are evenly distributed. Evenly distributed. And often what this means is that those components are also not easily distinguished. If I think of that saltwater example, when you look at saltwater, you can't actually see the salt in it. Salt water looks exactly the same as sugar water, right? Because those particles are very small, they're evenly distributed, they're not easily distinguished. And then the big deal here is that a homogeneous mixture is literally a synonym for a solution. So from now on, we're going to use those two words indistinguishably. Like we're going to talk about, I will use those two words in place of each other. A solution is a homogeneous mixture. So in a solution, we always have two parts. We have the solute and the solvent. And the solute, I always say, is what you dissolve. So it's the dissolved particles. So this is the, in my examples of salt water, this is the salt, this is the sugar. What is the solvent? It's the dissolving medium. What is it dissolved in? Right? It's not always water, but it's often water. And in sugar water or salt water examples, yeah, it's the water, the solvent. So remember, the solute is what you dissolve. I dissolve sugar in water. Okay? This picture is a picture that shows us what this actually looks like. And it has two different substances. On the left, you will see ionic compounds dissolving in water. And on the right, you have molecular substances. Okay, and they're both dissolving in water. What is the difference? Well, there's a great big difference here. The first one is that in ionic compounds, right, you will see that those ions will, fancy word here, dissociate, right? Those ionic compounds dissociate, break up into the ions that it's made up of, right? So here's solid NaCl. Right? Those ions are super attracted to each other, the positive sodium and the negative chloride. And when salt is dissolved in water, we would say those ions dissociate so that you have, let's see, this would be the negative, the green is the chlorine, the negative chlorine ions, and then you have the positive sodium ions. And this is really important. Look at how the water molecules surround sodium and chlorine, but they don't just surround it in any orientation. We're always going to see that though in water, we know that I'll draw it over here, that the red side is the oxygen side, the delta negative side, and the white side is the hydrogen side, the delta positive. So look at, like right over here, the negative chloride ion. We can see the positive side of water is attracted to, right? Coulomb's law, opposites attract, is attracted to the negative. The negative chloride is attracted to the positive side of water. And we see exactly the opposite here, that the positive sodium ion attracts the negative side of water. And we get a very similar thing happening with molecular substance, but no ions form here. When molecular substances, so molecular substances, that means all nonmetals, right? The example here is methanol, CH3OH. All of those atoms are nonmetals. When methanol dissolves in water, it doesn't dissociate, but we will see the same type of orientation, so that the negative side of water will be attracted to the partially positive side of methanol. So let's see if I can get sort of a good picture here with this. If this is this oxygen would be the negative side of methanol, because oxygen has those two lone pairs on it, and see how it is facing the positive side of water. Okay? So what type of compounds are most likely to dissolve in water? Well, what does it mean to dissolve in water? It must mean that it's attracted, right? Somehow you have to be attracted to water. Well, water has a delta negative and a delta positive side. So in order to be attracted to water, you must either be polar. So the first thing is you have to be polar molecule, or ionic, right? And those are the type of compounds that are attracted that will dissolve in water. But as seen by the previous pictures, they don't exactly dissolve in water the exact same way. When an ionic compound dissolves in water, it dissociates to produce ions, and that will give it different properties than a molecular compound that dissolves in water. And one of these properties will be whether it conducts electricity. So we have this other terminology that we can use to describe things that can dissolve in water. Okay, so these are all ways to describe a compound that will dissolve in water. So an electrolyte is a compound that will conduct electricity when dissolved in water or when it is molten. And it's another way of saying an ionic compound. So an electrolyte is a compound. An abbreviation for compound that we use all the time is CPD period. So a compound that will conduct electricity when dissolved in water or molten. So first of all, what the heck does that word molten mean? Molten is the word we use for the liquid phase of matter when the substance is a solid at room temperature. So, metals, you often hear that word molten used with like iron, because iron is a solid at room temperature. We don't say molten water because water is liquid at room temperature. So molten means heated up to become a liquid when it is a solid at room temperature. And what does this really mean? This really means all ionic. All ionic compounds are considered electrolytes. As a review, so we're talking about conducting electricity here. You will often be asked in AP chemistry, what do you need in order to conduct electricity? And there are two very specific things. The first thing you need charged particles. Those could be ions or electrons. And the second thing is that they must be free to move. That's why ionic compounds won't conduct electricity when they're solid, because even though they contain ions, they are not free to move. Okay, so a non-electrolyte, guess what? A compound that will not conduct electricity. when dissolved in water. And this is most molecular compounds. I'm not going to say all, because there is a subcategory of molecular compounds that we really don't talk about in first year chem yet, that we're going to talk about in just a moment. So what is a strong electrolyte? So if you are an electrolyte, you could be either a strong or weak. Okay, so what makes the difference between whether you're strong or weak? Well, both are going to conduct electricity. A strong electrolyte conducts electricity well. And why does it conduct electricity well? Because a large portion of its particles are ions. Another way to say this would be that it fully dissociates. Right? NaCl is a great example of this. When I take NaCl solid and I put it into water, it becomes Na plus aqueous and Cl minus aqueous. And 100% of those ions do that. Every single ion of NaCl will dissociate and then be able to conduct electricity. So then what the heck would a weak electrolyte be? Well, a weak electrolyte doesn't conduct electricity well. Why doesn't it conduct electricity well? Because only a small portion of the particles are ions. So what would that be? Well, we are going to look at a few of these. So most ionic compounds, we say ionic compounds are electrolytes. And you remember how you had those solubility rules that we learned? Those compounds that we said are always soluble will form strong electrolytes. But there are some compounds that we said were insoluble. And that was, we're going to do this all the time in AP chemistry, where I go, we learned that in first year chem. That was a lie. So when we said that, that those things were insoluble, that was a lie. They just were not very soluble. So one of the examples of that would be something like AgI. We learned that silver iodide was not soluble, and that is a false statement. The silver iodide will dissolve in water, but to a very, very, very small percentage, like way less than, honestly, like a 10,000th of a percent. I mean, a very small percentage. So we would say that that is a weak electrolyte, because is that going to conduct electricity? Yeah, but on a very small magnitude. More often than not, what falls under the category of weak electrolytes are weak acids and bases. And you're probably thinking, what the heck is an acid or a base? And that is a question for next year. So if you look at the pictures down here, you will see that here we have NaCl. I can tell because the purple and the green. So there's NaCl, fully dissociates. Look at light bulb, right? Crazy like that. I wonder what this compound is. How about this? CaF2? I don't know. Maybe CaF2 is not very soluble. If it is CaF2, green is usually fluorine when it comes down to this, then you can see a lot of the molecules or a lot of the ions are still together. But some of them have broken up. So therefore you see the light bulb, it is a little bit lit, but not bright. And then over here you have, this looks like a giant carbon, oxygen, hydrogen molecule. I'm going to guess that it's glucose or sucrose. right? Both of those end in OSE. That means that they're sugar molecules. And so this is a completely covalent compound. It doesn't dissociate at all in water. There's no ions when you take sugar and dissolve it in water, and hence the light bulb does not light at all. Okay, so that's the, what happens to different compounds when they dissolve in water, right? Molecular compounds will dissolve in water if they're polar. Ionic compounds will always dissolve in water to some extent. And then when they dissolve in water, we can use these terms to describe what happens to them. Whether they fully dissociate, partially dissociate, will conduct electricity well, not so well, or not at all.